Hello, you're welcome back to the channel. This is Brainx TV, a channel that is dedicated to ensuring that learners understand the basic concepts of mathematics, so we can together say that mathematics is the easiest subject ever to be taught in schools. Please do well to subscribe to the channel, like the videos, pass comments on any concept that you don't understand, and it will be addressed to your utmost understanding. As well, share the link of the videos to your friends so that they can all benefit from the easy concepts that we are learning over here. Then we can together see that mathematics is the easiest subject ever to be taught in schools. We are coming to the second part of our video of our topic, addition and subtraction of fractions. And today we are considering unlike fractions. We've looked at addition and subtraction of like fractions, and we are continuing with unlike fractions. So one may ask, what are unlike fractions? Unlike fractions are fractions that have different denominators. There may be two or more. As far as they have different denominators, those fractions are unlike fractions. Let's take some examples of unlike fractions. So you can have 1 over 2 and 1 over 3. Since the denominators are different, then 1 over 2 and 1 over 3 are unlike fractions. All right, let's take some examples on how to add and subtract unlike fractions. So let's start with the examples that we used over here. 1 over 2 plus 1 over 3. One may be tempted to say that 1 over 2 plus 1 over 3 is equal to the sum of the denominators 1 plus 1, 2, and 2 plus 3, 5. So 1 over 2 plus 1 over 3 equals 2 over 5. No, please, this is not correct. It has a few steps that we are going to go through before we get solution correct. Now, since they have different denominators, we are going to give the two fractions a common denominator, because with like fractions, the two fractions have the same denominator. So we chose one of the denominators as a common denominator. But with unlike fractions, because the denominators are different, we have to give it a common denominator. All right. We are going to use two approaches. So the first approach, we are going to use the equivalent fraction approach. The equivalent fraction approach. And then the second approach, we are going to consider the least common multiple approach. So let's start with the equivalent fraction approach. So, considering the equivalent fraction approach, what we are to do is to write equivalent fractions for both 1 over 2 and 1 over 3. So let's start it up. Please note that a video has been made on writing equivalent fractions. Please check up on the video to understand the concept of equivalent fractions, so that working out with the equivalent fractions here will be so easy for you to use. So 1 over 2 gives us 2 over 4. 3 over 6. 4 over 8. 5 over 10. And so on. But they move up to infinity. Now let's say that of 1 over 3. That gives us 2 over 6. Now the idea is that we are writing equivalent fractions for each of the given fractions. Then the fraction that has the same denominator with the numerator, with the first fraction and the second fraction, we want to choose those fractions. So with 1 over 2 and 1 over 3, we've seen that 1 over 2 has given us 2 over 4, 3 over 6, 4 over 8, 5 over 10, and so on. 1 over 3 has given us 2 over 6. You can see that This one has a denominator of 6, and this one also has a denominator of 6. You're going to use 3 over 6 for 1 over 2, and 2 over 6 for 1 over 3. Please hope you understand it. So, coming down here, we're going to replace 1 over 2 with 3 over 6. So this will give us 3 over 6 plus, for 1 over 3, represent it with 2 over 6. 2 over 6. Please hope you understand what you are doing. We wrote equivalent fractions for each of the two fractions. And we selected the fraction that has the same denominator with both fractions, because we said that we have to give the two different fractions a common denominator. So 1 over 2 has 3 over 6, 1 over 3 has 2 over 6. So since the denominator is 6 with 1 over 2 and is 6 with 1 over 3, we're going to select those fractions with the same denominator, and we represent them with the equivalent fractions. So the equivalent fraction 1 over 2 is equal to 3 over 6, and for 1 over 3 we have 2 over 6. Now they have the same denominator, so we can apply the like fraction approach to answer this. So this will give us 3 plus 2 all over 6, and this equals 5 over 6. Please, I hope you understand what you are doing. All right, let's take the alternative approach of finding the least common multiple. All right, so with the LCM approach, we're going to list the multiples of the denominators 2 and 3. So we get the first common multiple to 2 and 3. So 1 over 2 plus 1 over 3. Write the multiples of 2 and the multiples of 3. So for the multiples of 2, we'll get 2, 4, 6, 8, 10, 12, and so on. The multiples run up to infinity. Then the multiples of 3, we get 3, 6. Now, when we get to 6, we've gotten the first common multiple to 2 and 3, and that is 6. So we're going to select 6. All right, so we will give it our common denominator of 6. Now, the next thing to do is to check the number of times each denominator will divide the least common multiple. Number of times 2 will divide 6, number of times 3 will divide 6. So you can see that 2 divides 6 3 times, and that is 1, 2, 3. So 2 divides 6 3 times. So we multiply the 3 by the numerator here. So we get 3 times 1. That is for the first fraction. Plus, then take the second fraction. We check the number of times 3 will divide 6, and that is 1, 2. So 2 times. So multiply 2 by its numerator, which is also 1. Then we get 3 times 1 equals 3, plus 2 times 1 equals 2, all divided by 6. And 3 plus 2 equals 5, and the denominator 6. So that means 1 over 2 plus 1 over 3 is equal to 5 over 6. So either approach that you use will give us the same answers. Please, I hope you understand what you are doing. All right, let's take another example. All right, so we have 2 over 3 plus 4 over 5. We're going to use the equivalent fraction approach. So for the equivalent fractions of 2 over 3, you'll get 4 over 6, 6 over 9, 8 over 12, 10 over 15, 12 over 18, 14 over 21, and so on. All right, then we find the equivalent fractions for 4 over 5. That gives us 8 over 10, 12 over 15. You can see that we've got a common denominator of 15 for 8, 10 over 15, and 12 over 15. So 10 over 15 for 2 over 3 and 12 over 15 for 4 over 5. We're going to replace these fractions with their equivalent fractions. So we get 10 over 15 plus 12 over 15. Then we can, since they have the same denominator, we can easily add them up. Get 10 plus 12 all over 15. Then 10 plus 12 gives us 22 over 15. Please, I hope you understand it. All right, let's take the LCM approach. So we will write the multiples of 3 and the multiples of 5. So for 3, you'll get 3, 6, 9, 12, 15, 18, 21, and so on. That of 5, you'll get 5, 10, 15. You see that 15 is the common multiple for both 3 and 5. All right, so we get our LCM to be 15. Now we ask ourselves, how many times would 3 divide 15? And that is 1, 2, 3, 4, 5. So 3 divides 15 5 times. So we multiply the 5 by the corresponding numerator. So this gives us 5 times 2 plus 10 times 5 will divide 15, and that is 1, 2, 3. 3 times. So we multiply 3 by 4. So 3 times 4. Now 5 times 2 equals 10. So we get 10 plus 3 times 4 equals 12. 12, all divided by 15. And then 10 plus 12 gives 22. So we get 22 over 15. Please, I hope you understand what we have done. All right, let's take this question as we try them on our own. All right, so let us try this question. 2 over 4 plus 5 over 6. Please do well to pause the video and apply the approaches that you have used. Please, you're not supposed to do all the two, but to choose the one that you are going to be very conversant with, or you understand the most, and you apply it. You can see that from all our solutions, whether you use the equivalent fraction approach or the LCM approach, you get the same answers. So please do well to pause the video and work out the solutions on your own. After that, you check on the solution to the question. Thank you. All right, so this is the solution to the work. Please, I hope you got the same thing. Now, I'm going to give you one more question with the solution, then you work out the steps to guarantee your understanding with the concepts. So we try 2 over 3 plus 1 over 4. And over here, the answer is equal to 11 over 12. Please do all to work it out towards this answer for whichever approach that you're going to use, whether the equivalent fraction approach or the LCM approach. See you in our next videos. Bye.